You push the button. This is a matter compiler for genetic material. And what's actually frightening for me is I wish I could explain it better, but when I went online to find documentation for DNA synthesizers, it's actually easier to find documentation for how the food replicators in Star Trek work. But nevertheless, what this is practically, to think about it, is a matter compiler for genetic material. And since the living world that we care about runs on genetic material, this is an important technology to be aware of. And what's very interesting is this technology is getting better very quickly. So on the left of the plot, this is years and then stuff over time. The left plot is features per chip on microprocessors. It's Moore's law for computing, a log scale. And then the middle plot is how much DNA we can sequence in a day, if you're just reading out DNA. So in 1990, nobody had sequenced a bacterial genome. In 1995, the first bacterial genome is sequenced. In 2000, 5 years later, the draft of the human being we've been sequenced. So somehow in the 1990s, we go from not being able to sequence anything to being able to sequence people. That's not because the geneticists got 10 billion times smarter in 10 years. It's because the technology for reading out DNA got better. The last plot on the right is how much DNA you can write or compile in DNA synthesizers in a day, going from the information to the material. And that's lagging behind sequencing because our synthesizers aren't very good. You need to make something and then sequence it to find out where the mistakes were so you can fix your synthesizer. But it's going up at least as quickly. And in this year, this is an old paper, 2003. In 2007, this is the year where a bacterial genome is reported to have been constructed from scratch, where a mitochondrial genome has been constructed from scratch, a chloroplast genome.